as a statistician, you need to recognize if someone's trying to mislead you with a graph. And a lot of times in statistics, things can be reported and they are actually accurate, but they craft a picture around a message that they want to send, and then they adjust things accordingly. So what we're after here is to look at a couple of graphs and try to establish, what is misleading about them, what is truthful about them, but what is misleading. And so all of these graphs have accurate numbers in them. It's just that they want to try to send a signal to you that things are more extreme than they really are. And so we'll look at, I think there's 2 on this page, and then another 3 on this next page. So a couple of things to look out for in misleading graphs. Steps needed to burn calories. All right, so this one is about exercising and how many steps you have to take to actually burn calories. And I guess we know what this is saying is that if you're going to drink a 12-ounce beer, in order to burn off all the calories that you've consumed from this beer, you'd have to walk or take 3,220 steps. To work off this soda, 3,000 is a 12-ounce soda, I imagine it has sugar in it, 3,450 steps. Same thing for the cheeseburger and the donut. So you can see. Now they've got pictures here, and it looks like they also have maybe a bar graph here. I can't really tell this one, but it's kind of comes in here like this. Picture's not that great. So the actual numbers that they're using here, the 7,500, 7,590, this really is probably pretty close to the number of steps you'd have to take in order to work off that cheeseburger. And it really is about 5,750 steps for you to work off that donut. So that's accurate, but what's misleading about it? That's what we have to ask. Okay, so all we know here is that this hamburger bar, this cheeseburger bar is the largest one. So I guess you have to ask yourself, where do you start? It looks like they're trying to suggest that the cheeseburger takes an unusually long time to burn off calories. And when you look proportionately, you have that amount, and you have this amount. And maybe if you just put a vertical scale in here, everything would look okay. So if this is 5,700, then if we doubled it, this might be twice that amount. But here we have something that's 3,450, and if we doubled that here to here, it would take it up to there. And then it looks like if you went that same amount, you'd get up to here. So something's off about that, because if we treat this as the unit of 3,450, then this also is 3,450, and this is also 3,450. So if you add those 1, 2, 3, 3,450s, then you're up around 10,000. And this only goes up to 7,590. So something might be off at the scale. It's unclear where the scale begins. Now, if you're going to say the 0 is down here, then this distance here would be 5,750. And this distance here, about right here, is 3,450. That's probably okay. But what makes it maybe a little bit more misleading is if you measure the width here, usually in a bar graph, the widths of those bars are the same. But if we went the same, and I can get a ruler out here to show you, it looks like it's about, it's certainly less than an inch there. Looks like it's about, whatever that is. Yeah, 5/8, 6/8. Okay, so somewhere between 6/8 and 6/8 and 7/8. But this one here, the length is well beyond, the width of this one is well beyond the 1 inch. So because the bars are wider on the cheeseburger than they are some of these other ones, if you take a quick look at this graph, because of the area of that bar, it might appear to you that it takes a lot more steps in order to burn off the calories. So the bar widths differ, and that makes the number of steps that it would be required. If you just look at the visual representation, it looks like they're trying to suggest that it takes a lot more, many more steps in order to work off that cheeseburger. Right? And since the bars contain much more area in them, they appear much bigger than they normally are. The other thing is you know, you've got these icons here, and relative to one another, probably the beer bottle is taller than the can, and that's not at all clear. And compared to the soda can, this would be a very big cheeseburger. So again, the cheeseburger is very high here, so they might be suggesting to the reader that cheeseburgers take a lot more steps to burn off. So if you wanted to get something more accurate, you make the horizontal scale accurate and then have these bars about the same width. And of course, so that's how you could improve it. So look for that. Look for unequal bars. Look for these pictographs where these pictures actually take you higher than they otherwise should be. All right, let's look at the next one. This is median income for females. Median is what we'll look at today. It's kind of like an average in 2013 dollars. So they take inflation into consideration. The graph shows the median income for females from 2007 to 2013. Very good. And then here you see the average coming up here. The scale is correct. This is the income these years. It's a, you know, it's a bar graph, so they're going with each year. But it really looks like, and what's misleading about this one is it really looks like there's been a dramatic decrease in the salaries of females over that 6-year period or 7-year period. And in fact, there was a decrease, it looks like. But if you look at this number right here, the vertical scale does not begin at 0. So what that does is it magnifies the differences between 2 consecutive years. So it looks like a dramatic decrease, but if you redrew this graph, so you had, say, 10, 20, and $30,000, so that you did in fact start at 0. So it looked like this. And then you plotted those bars for 2007, 2008, 2009, 2010, 11, 12, and 13. And you plotted those, you'd still see a decrease, but the decrease will not appear to be as extreme as it does here. So for example, in 2007, it looks like we're up at 23,500. So 23,500 might be about right here. So this would be your bar. But if you go with the next one in 2008, it looks like it's 22,500. So if you did a bar on that one, 22,500 would be about right here. You can see there's been a decline, but it's not a dramatic decline. Even these lowest bars in here, like 2011, it's the smallest bar of all these around it. You know, this one here is somewhere between 21.5 and 22. And so even in 2011, the bar is going to go up to about right here. Yeah, well, I'm not going to get them quite right, but this one might go up a little higher. All right, so it would look more like that. All of these are in the, you know, say the 21,000 to 24,000 range. And so if you look at it this way, it doesn't appear that there's a dramatic decrease at all in the women's salary. Okay, so it's misleading because we do not start at 0 on the vertical scale, which makes the bars look like they're dramatically decreasing. So it's misleading. The data are accurate, and it really depends on what you would like to show when you're presenting this. It might make sense in some cases to draw a misleading graph if you really want to emphasize one particular aspect. Okay, so the graph seems to indicate a dramatic decrease in the salaries of females. And if we redraw the graph where we just start at 0, the decrease doesn't seem as dramatic. So this is a misleading graph. Accurate, but misleading. This one has a similar situation. It looks like from 1992 to 2004, there's been a dramatic decrease in the percentage of workers that are injured. But again, you can see this one here does not begin at 0. So if you did begin at 0 and you went up to 0.2, and this was 0.1, 0.10, 0.20, you would see these two bars at 1992 would be much closer to one another. So 192, it looks like it's up just slightly higher than 2, so it would come up here. And then 2004 is about 0.18. So 0.18 would be about right up in there. Same graph, same data. This one shows dramatic decrease. This one shows a decrease, but not as dramatic. This one here says, claims that the rate of workers' injuries has been reduced by 67% over a 12-year period. Here's the 12 years, reduced 67%. So this is about 0.202, and this one here is about 0.180. Now, the reason that they're claiming that this was decreased by 67%, 67% is about 2/3. So if you add another one and another one, so we went from this amount, and this is 1/3, so it decreased by 2/3. They're looking at the height of the bars to make that determination. And we know that this is not true, because if we take the amount of the change and then divide by the original amount, we can calculate the percent decrease. We've done this in this class many times. So the decrease was not 67%, as would indicate by the graph. Perfectly reasonable to think that things have decreased by 2/3. But we can see just by doing this calculation here that that's not the case. Okay, so if we convert that decimal into a percent, we can see that there has been a decrease, but it's not 67%. It's not 2/3. It's only 11%. So look at the original graph and say, wow, it's only 11% decrease 12 years later. Okay, so another misleading graph. And what do you think about this one? So percentage of income spent on housing, percentage of income spent on food, percentage of income spent on transportation, other. Those percentages don't add up to 100% because there are other things that you spend your money on, but still all accurate. One of the things here that you might say is that, well, if this bar is 18%, if you doubled it, it would come all the way to here, and then over here would be 36%. So clearly we're not starting, who knows what you're starting at here. Relative to one another, these numbers are accurate. For example, 33 is bigger than 18, is bigger than 15, is bigger than 11. But those bars are not proportionately accurate. And there's no indication about, if this starts at 0 and you go up to 33 from this way. If you start from 0 here, and this is 11, then if we doubled that, then over here would be 22. But on this graph, it says 33. So somehow the vertical scale is off, or I guess it's the horizontal scale here, is wrong in some way. We would expect double 15 not to be greater than 33%. So I think if you just start at 0 and do a new graph, you can make it so that it's not misleading. And then we have a pie chart, the last one. This is the, if you look at the most valuable player that is elected or chosen every year, what position does the most valuable player of the league play? And you can see over the years from 1931 to 2013, over a third of the time, the most valuable player was an outfielder. 11% of the time, the most valuable player was the pitcher, and so on. Probably what you should do is you should add up all those percentages to make sure that they add up to 100. But the 3D nature of the graph maybe throws it off a little bit. I guess what I could point to is 11% here. See that slice there? It's kind of in the background. Compare that to the front slice, 11%. They're supposed to be the same size, but because of the 3D nature and kind of the slanted back, it makes it somewhat misleading. So generally with bar graphs and pie charts, you should avoid the 3D effect because it really distorts the graph a little bit. So I think if you just change this to a 2-dimensional pie chart, then it would be accurate.